Vicky,
Hiya, I'm Michael.
and we're going to talk about the Raspberry Pi Pico.
This is the Raspberry Pi Pico. This is a new $4 microcontroller from the Raspberry Pi Foundation. So here we have the Pico board itself, and we've labeled all the pins here to make it a little bit easier to see what's going on. So you can see there are 40 pins in total, but they're used in different ways. So the first set you can see I'll talk about are the GPIO pins, GP0 to GP28 in green.
So what's a GPIO?
So GPIO is a general purpose IO, and typically this would be configured as either an input or output. So this would be for buttons or triggering other events, and they can be reconfigured in different ways. They're very similar to the Raspberry Pi GPIO pins. Next we have 3 ADCs. So you can see them as ADC 0 to 2 on the right hand side, a slightly darker green.
What do you do with ADCs and what is it?
ADCs are analog to digital converters. They're used usually for measuring voltages between 0 and some voltage value, for example 0 to 5 volts. So it's how you get analog signals. So they might be used for sensors to get different things like temperature and things like that. Next we have 2 UART controllers. You can see them marked as UART 0 and UART 1, and you'll notice that their different sets of pins can be configured as UART pins. So again, this is the GPIO. You can pick the sets of pins you want to use as UART controller.
And I can see the UART, there's a TX and RX. So I know from my other project that it's like transmission and receive. Is that the same here in this case? I assume it's the same because it's a Raspberry Pi, right?
Yes, it's a serial interface.
And what's next?
Then we have the SPI, so the single pin interface. And you can see again, there's an SPI, there's 2 of them, so there's SPI 0 and SPI 1. And again, you can see sets of pins can be configured as either 0 or 1. And the single pin interface is used for controlling different types of hardware. For example, some sensors will use the SPI interface. Then we have 2 I2c controllers, and again, you can see it's I2c 0 and I2c 1, and again, its sets of pins can be configured. This is typically used for controlling other types of hardware, so it's typically either SPI or I2c or possibly UART in some cases. Then we have, there's 16 Pwm controllers. They're not shown here, but they're typically configured on the GPIO pins, and they're used for controlling motors like pulse width modulation.
And how do you know which pins to use then if they're not?
So
is it shown on the pinouts here?
So you configure them in the GPIO, so you pick pins to be. And then finally we have USB, which is USB, but it can be used as both a host and a controller, so it can act as a device, say plugged into your machine, or it can control other devices. And then finally, one of the more interesting sets are the little debug pins at the bottom. These let you debug the hardware via a couple of pins in a serial interface from a debugger on your machine that you're developing with. So this actually lets you connect directly in and debug what's running on the hardware.
There's 3 little pins there, isn't it?
Yep.
So, good question is, so now I have a Pico, and it's completely brand new out of the box. So, especially for people who want to get a Pico, how do you get started on this?
Okay. Simplest thing is go to raspberrypi.org, and if you just go to the kind of hardware page, you'll see all the different bits of hardware, and the one we're interested in is of course the Pico. And if you go down there, they have a nice little get started, and they'll run through different ways to run code. Now, there are lots of different ways to program a Pico. You can program it via sort of different visual tools, C, C++, Python as well. And so the typical way to get going is you'd follow one of these guides. So for example, if you want to run C or C++, which is a bit more closer to the hardware, so that'll be the fastest way, you typically download an SDK and you run it on your laptop or your Raspberry Pi, and you would write some code, compile it, and then it would download onto the Pico, and the Pico would restart with the code and then be running with it. For Python, you can run MicroPython, for example. So when it starts up, it actually has a little Python interpreter. So to get that going, you typically download the little file and drop it onto it. And again, it restarts in MicroPython, and you can write Python code for that.
Just want to jump in there with Python. You can also use CircuitPython as well, not just MicroPython.
Yep, that's correct. CircuitPython is a version of MicroPython.
So
So both the same thing.
for people who are interested, just hop over to Adafruit. Do a search for Adafruit and Pico and CircuitPython. You'll find the information there as well.
Yep. Typically, what you find is MicroPython or CircuitPython are good for sort of prototyping stuff, but quite often in an embedded controller like this, you don't have a huge amount of CPU, so you quite often want something. You might wind up having to make it go a little bit faster. So that's why you typically write it in C or C++, because that's much closer to the hardware and typically runs much faster. And so it's good, so you can do things like a limited amount of data processing in real time. Maybe, for example, for audio, which is very sensitive to speed, you could do real-time audio generation with using some C and C++.
And that was our video on Intro to Raspberry Pi Pico. Thank you, Michael, for
No
that.
problem.
And don't forget, today is also Pi Day. And if you head over to the Raspberry Pi official homepage, they have some information about what's happening today. They have an event at 7 p.m. this evening. So check out their page. And that's it for us for now. And hope to see you next time. I'm Vicky.
I'm Michael.
Bye.
Bye.